Hello everyone. Today I am going to discuss one problem on the k nearest neighbor for a regression model. Okay, so this particular question is a standard question from the NPTEL course Introduction to Machine Learning. Okay, so so this question, let us just take a screenshot here. So this question is saying that one data set is given and we need to apply the KNN model, but for the regression task. So this KNN model, it can be used both for classification, okay, and for regression. And the value, the nearest neighbor value that I need to consider is 3, okay, and I need to predict the y data point, that is nothing but the target feature, okay, the y feature corresponding to these this one data point, this one new data point x1 comma, which is denoted as x1 comma y x2, and so this data point is in two-dimensional space. Okay, that's why there are two feature x1 and x2. Okay, so the data set also that is given, as you can see, it is having two dimension, two features x1 and x2, and the third feature y, it is nothing but the target feature. Okay, so here we need to use Euclidean distance as a distance measure to have the nearness, to understand the nearness of these new data point to these given data points in the data set. We need to calculate Euclidean distance. Okay, so for that, how what is the formula for Euclidean distance? Euclidean distance is a square root on this. Suppose this particular data point that is given, it is in two dimension, right? So that's why I will be having also here this x1, the given data point, x1 feature, and the x1 feature of the new data point whole square plus the second feature, the x2 feature, minus x2 feature of the new data point whole square. Okay, this will be the Euclidean distance for the data points having two dimension. If I am having multiple dimension, then I can keep on adding these distances. Okay, now what we will do here, we will calculate this Euclidean distance. So I will just extend this table here. Now you can see, to calculate the Euclidean distance of these new data point with the first row of the data set, how we will proceed? We will proceed using this formula again. The x1 point is what? 1, that is this one I am taking, minus the x1 data point of the new data point for which I need to predict the y value. Okay, so that is also 1 here whole square equal to the x2 data point here is what? 0 plus this is plus 0 minus the x2 data point of the new data point is 0.5 whole square. Okay, which will be equal to what? This one it will be 0 plus it will be 0.5 whole square. Okay, which is equal to 0.5. So the Euclidean distance of the new data point from the given data point of the first row is 0.5. Okay, similarly we will calculate for the second data point. So how we can calculate? Square root the x1 data point. X1 data point is again here 1, I will be putting 1, then x1 value of the new data point, that is again it is also 1 square, plus the x2 data point is what? 0.5. So 0.5 minus the x2 data point for this one is again 0.5. So this is also 0.5. So one mistake here I have done. Here the first data point, it is not 1 but it is -1. Okay, so it will be -1 equal to, so here these two will cancel out, and this one will be square root of -2 whole square, which is nothing but square root of 2 square, which is nothing but 2, right? So the Euclidean distance so the Euclidean distance for the second data point here is what? 2. Similarly, we will be calculating the Euclidean distance for the from the third data point, and we will follow the same procedure only, taking square and then square root. Okay. So the final calculation value I am putting here for the third data point, Euclidean distance. This one was for the first one, second one. For the third data point, this value is 1.12. Then for the fourth data point, this Euclidean distance value is 3.61. Then for the fifth data point, this Euclidean distance value is 0.5 again. For the last data point, this Euclidean distance value is 2.5. Okay, so these are the Euclidean distances. Now what we will do, we'll add one more column here to give the rank. Okay, like I am going to sort this data actually, this Euclidean distance, and the nearest most distance I will be giving the order 1. Okay, then the next nearest distance again here is 0.5 only, so this one I am giving as 2. Now as you can see here, both the distances are same, so why I am giving the first row as rank 1 and second row as rank 2. We can do the otherwise also. We can give the first rank to the second data point as well. So this is one conflict that has occurred, but this rank will ultimately affect on the y value also. Okay, because the y value for the first row is 2.65. okay, whereas the y value is 0.6. So when considering this k nearest neighborhood, if I choose this 2.65, whatever predicted y value I will get, that will be different from if I choose the y value as 0.6. okay, but for this particular question, although this generally this kind of conflict it does not occur in a data set, even if it occurs, we need to like resolve it in some way. Some criteria will be given. This same Euclidean distance value for this particular question will not affect the final y predicted value, because the k value given is 3. So when k value given is 3, both this first 0.5 and second 0.5 will come, we will consider for calculation the y value. Okay, then the second rank is okay, then the third rank will be given to this data point. Okay, 3. So the minimum distance 0.5, 0.5. Then the next shortest or nearest distance is 1.12. Then the next shortest distance is this 2, that is 4. After that, the next shortest distance is this 2.5, and lastly it is this one 3.61. okay, so this rank will only give which one, it will show which one is the shortest one, which one is the nearest data point to this particular new data point. Okay, so this rank adding of this column rank is important when we have a very big data set. Okay, so this data set is a smaller one, so from this data set it is easier to find which are the nearest Euclidean distance value. But if my data set is a very lengthy one, then in that case finding out this rank will help in solving the problem. Okay, So here, since I need to consider k equal to 3, so the data point that I will consider is this one, with having rank 1. Then the next data point having rank 2, this y value I will consider, and the next data point that is the nearest one under k equal to 3 neighbors, so that is 1.95. Okay, so to find the predicted y value, okay, predicted y value for the given data point 1.0, this is 1, 0.5 will be what? What will be the y value for its neighbor, the 3 neighbors that we have considered, that we will add up and then take average. 2.65 plus second one is 1.95 plus third one is 0.6, okay, divided by 3, because 3 neighbors we need to consider, and this final value is 1.733. okay, so this will be the predicted y value for this new data point. Okay, so what is given in the options? So here, out of all the 4 options, 1.733, that is the correct answer. Okay, so again, if we see here, this conflict that has occurred here, but it is not affecting us because I am taking k equal to 3. Okay, but if I take k equal to 1, in that case either I have to consider this 0.5 distance, or I have to consider the other 0.5 distance. Okay, and if I consider the first one, then the y predicted value will be the one, because it is k equal to 1, it will be 2.65, whereas if I consider the second one, then it will be 0.60. okay, so to resolve this kind of conflict, already the criteria will be given, that which particular k value we need to consider. So thank you.